my test. Good afternoon, student. Can hear? Okay. Thank you. Okay. So school request me to do some revision for this part before your final exam. So I will just for today I will just go through the last semester final exam. Maybe some of the part when you do the when you're answering, it may not really clear. That's why you wouldn't get mark for that part. So I just go through, and maybe we need some more time to meet again. So after today, you will read through all this part. Then maybe you need to do one more past year exam paper. And next time we meet again and discuss. Okay, so I just go through. So today's class will be a little bit short. If you after today's class, if you have anything to ask, please ask me through WhatsApp. Try to answer. Okay, so past year exam paper last sem. This part. We have first one here. We have one table. Then I'll ask you to identify data, info, and knowledge. So we have this part, and based on this, we need to explain something. So this one, if we didn't have any comparison, of course, this one is only data. And what we need to do is we need to mention the collection of this data is the price for the, let's say, rental or the average price of the residential apartment. So this one is the price. After we collect this one is the data. Then based on the info, the question say we need to the agent need to advise those who want to rent or buy this apartment, give some kind of info. So the quarterly and yearly percentage, this one is the information that agent need to give to the one who want to rent or buy the apartment. So the quarterly information show whether it's a sales or it's the rental, how many percent, whether it's increasing or decreasing. So this one is because the question didn't mention whether it's a sales price drop or up or the rental price sales or whatever. So it is up to you. Yeah, it is up to you to describe. Okay. So if the question didn't mention clearly, then it's up to you to describe. So this part is the info. The agent can recommend, since the price here is already dropped, it is a good time to buy. If the price is up, then on this one may not be so suitable at this time. Okay, so this one is the information that agent can give. So after we combine everything, the knowledge, the agent already have the knowledge for this part, then it can help the customer to choose the apartment based on their target. Let's say how much they want to pay for that. So if the agent only able to pay 888, then the one who want to rent the apartment only can afford to pay lowest price, then the agent only can recommend this part. Okay, so this one is the data, info, and knowledge. For this part, data, info, and knowledge, we also have some others chapter for. In the chapter 1, we have this quantitative or qualitative. We have a source, we have nature, a lot. Okay, so better since this one is the common exam question, it will be good you go through this part again. Okay. And the next question here is, Mr. Ahmad run this grocery and he want to expand to the nearby city. So previously, he only used a Java programmer, right? Java program to monitor the business transaction and inventory. So when we see this Java um, transaction, the most probably mentioned is a read and write to a file. Okay, so this one is the question, and we assume this one is read and write to the files architecture. So we need to explain what type of a data architecture would be suitable for his intent for the expand, how it can uh, how it can use the new database architecture to overcome the current one, the Java to file limitation in the current system. Okay, so the suggestion, of course, will be the three-type architecture. Some students are using some others method. Yes, it's possible to use since we didn't have one fixed answer, but this one is a suggestion. Okay, for in the marketing scheme, this one is the suggestion three-type architecture. And before we talk about this three-type architecture, since this one is a revision, and I need to go through this part. You need to know why the Java and the text file is not working. So, not working well, of course, starting when your business is very extremely small, read and write to a file or a data file should be okay. But when your company want to expand to maybe a few branch in one city, or even the like 99 Steam open this branch all over Malaysia. Even let's say Ipoh, we have a lot of these branches, 99 Steam branches. So it is not good to use only read and write to a file or data file system. Okay, so the disadvantage of this file processing, we need to understand why it's not good, because keeping all this file is not, it cannot communicate. The files, if the file size is too big, it will be easy to corrupt. Of course, need to go through all this. Okay, so this one, if you miss out, maybe this time you need to read again. Okay, so this one is the disadvantage of this file processing. Then continue. If we have a one file server, previously, let's say each workstation keep one file, one text file or a data file. It hard to synchronize for all others workstation. But if we have a one file server, then it is another topic. Okay, it is another topic. So we have this significant network traffic. Read and write. It need to keep the file open, close, and copy of all this to the workstation is time consumed. This one also have a concurrency problem as well. So not only a database DBMS have a concurrency problem, but for this file server, we also have this concurrency problem. When you request the file, write back to the file server, it may take some time. Okay, so although this one is only for the LAN part. So you need to explain why file server is not good, file processing is not good, then only come to this treatment. Of course, based on the question, previous this two is not needed. What you need to mention is only this part. But who knows? The question will change a bit. Ask you to mention why you want to use this, why you cannot use this file processing and file server, and want to change it to this three types of client server. Okay, so we have an advantage for this three type client server. Think client. So for this part of for this image, think about website. So I think you already have developed a lot of program since I think this one is a final year, right? Even a final semester. So you should already develop some web page and web server communication, and even you have read and write to one, let's say, um, database. Okay, so you can see from here the client, the first type, and the second one is the application server. So this one is doing the control, and only everything is okay, it come to the database server and save or write something to the database. So this one we have a one web page, similar. We think this one is one open a one web page using your web browser, and after that you're doing the connection to the server, web server or application server. Then this application server, after authenticate, after checking everything ready already, only it connect to the database. And if everything is okay, you have the right to read and write to the database, then only do this part. So the connection from this is very short. So when you type everything, then when you press submit, it just do one submission, and it will just go through all this. It take very little time, little data, so the speed will be very fast. So that's why we say thin client. So it requiring less expensive hardware. So previously during our lecture times, I did mention for this, I think 7 to 8 years ago, when Xiaomi just come into Malaysia, they opened one time for few times. I think few times, everyone can buy this Xiaomi phone from the local website. So you need to log in, uh, um, register, and you buy something, some handphone from this Xiaomi website. Of course, that time this Lazada or Shopee is still not there yet. So of course, um, using this kind of sales, the a lot of buyer log in, buy, and let's say maybe a 10 to I think between a 10 minute, this thousand or few thousands unit of these handphones already show up. Okay, so based on this, we can know that the connection to the web server, it takes very little time. The traffic is less. So this one is how we say thin client require less expensive hardware. Okay, then continue, we have this application maintenance centralized. So the application for this part, connection to the client, connection to the server. Every client, when you buy one new computer, it actually can have every computer should have a web browser. So you can already doing it. You do not even need to buy any others program. Okay, easier to modify or replace one type without affecting the other. So if anything of this have problem, you just buy a new one. Okay, so separating a business logic from the database function make it easier to implement a load balance. So we have many clients connect to the application server. So this application server decide whether the request need to pass through a database or not. So if a yes, then only a pass. If no, then it will just return the request, say a reject or whatever. Okay, so this one, if the business expand, you may even you may just need to buy few more application server. then it can cater all the problem. So easier to implement load balance. So if the switch or this um, um, first level switch hardware hardware router switch, we have this switch. Then for if we have more than how many percent of this client connect to this application server, it will just divert the request to different application server, and this one is what we call load balance. Next one is a map natural to this web environment. So this one is what just now we said. Every of this client is open um, this web browser, and it quite similar. Okay, quite similar to this connection to this web server. Okay, so this one based on this, you suggest Mr. Ahmad why it want to change it to this T-type client server. Okay, so everything is good. What you need to do is buy all this hardware, simply install some program, and you can get it. Okay, so this one is for question 1A, B, and start from C. We have this name called thing called anomalies. This one during our midterm, we already have this question. But most of the students didn't get quite well for this part. I think more than half didn't get full mark. So we just pay attention to this again. So hopefully if this time the test still have this, we better get full mark for this. So for insertions anomalies, you can see from here, we have a one, this one is a one record. And if we have this, if we want to insert one customer, let's say B, now we have a B25, we want to insert another one, B26. But this B26, let's say Alan, haven't decided or buy any package yet. So if based on this table, this B26 Alan is not able to insert into the database because he didn't choose any package yet. So until Alan choose one package or a new package, they're only able to insert into the database. Okay, so this one is what we call insertions anomalies. Occur when there is a new customer to be inserted into table, but haven't have any package yet. So this is insertion anomaly. Okay, next we have this deletion anomaly. Same thing. If we delete this Benjamin B25, if we delete this customer, since it is one record, if we want to delete this Benjamin, we also delete this package as well. So we actually have this package, but if we want to remove Benjamin, of course this package no longer there because this one is the whole record. So this one is deletion of deletions normally occur when the package ID LG11 is cancelled or the deletion of this customer, and either one will be removed. But it is not true. You delete this, the customer still register inside, but it does not exist in the database. Next one, modification. We have a few records here. We change one PT. If we change this PT22, all the corresponding record must be updated accordingly. Spelling which should be occur these are inconsistent. So previously for insertion, one insert, another one is not there, then it is not correct. Second one, deletion of one disk will train to deletion of the customer. Next one, we have this modification. Modification of something here will also change the record for all other part. Okay, so this one is if we didn't change it, then it will be data inconsistent. So this is the three kinds of these anomalies. So for your part, what you need to do is based on the table, you need to give one example, not only describe, not only describe, but you need to give one example, which one delete will cause the problem, which one is added will cause the problem, which one modify will cause the problem. Okay. Okay, then the next one here we have this thing called normalization. Okay, we have the question asks, the question asks, based on this table, you judge whether this one is a normalized, first normalization, second normalization, or third normalization. So if you read from the PowerPoint, you already mentioned if we have anything that is empty, if based on this table, we want to insert the record into database. What we need to do is we need to fill out all the empty space. So package ID KK55, we need to fill in all this. If this one is Excel, we just drag and drop. So the Kota Kinabalu, all this will be drag drop, then fulfills all the empty row, empty column first before we actually doing the first normalization. Okay, so the first step, what we need to do. So that's why, because this part is still empty, we say that this table is in unnormalized form. If you missing this part, then you won't get that. So it contains anomalies such as insertion, deletion, modification table. Besides, there is a data redundancy. So you can see data redundancy. We have this L66 here. We also have H81 and H81. So this one is the point. It have a data redundancy, then it is not in even the first normalization. Okay. Okay, then I'll continue. We have this question here. Identify functional dependency. So we have three functional dependency here. Package ID, this one package ID. Functional dependency for this table. We also have another one, customer ID, for this part. Okay, then we can even build another functional dependency for this part, trade guide. Okay, so this one is after we break this table into two. Package is for package, tour guide is for tour guide. Then we have this third functional dependency, trade guide. Okay, so after we fill in all the empty, you can see we have two tables here. So the first one we have a package, and the second one we have this customer ID. But since we have some redundancy data here, what we need to do is we need to break it for first normalization. We need to remove the repeating group. So this one L66 and L66 here. So if we make this one as a one table, then this is repeating. Okay, so what we need to do is, because L66 register in this package KK55, at the same time you also register in this PT22. So what we need to do is we need to create another table. The table name is up to you to decide. Okay, so this one we have this booking, and we need to understand one point. Data and data need to have a one connection. If this one is standalone and this one is standalone, and it didn't have any connection, then how are we going to link these two together during the query? Okay, so that's why we have this forum ID. So package ID, customer, the booking for this part will also link it to the package. So for this one, starting of course is we want to build one customer table, but since we want to link it together, then we need to have another one foreign key for the package ID. Okay, so this one is linked together. So this one is the first normal form repeating group. Okay, so I assume everyone will have a problem to decide what to add or what to remove for the normalization. So you can try to snapshot this and think again. When you receive another past exam paper, you try to see whether I have this thing or not. I also will share one midterm for 2022 year 2022 this sem midterm, and hopefully you can try. So you actually have two paper to go through, see whether you have this normalization. Okay, so for second one, we remove this partial dependency, and then the third one we remove this transitive dependency. So previously we have this two table, and for this part booking, since the data for customer ID will always be repeating, so we need to break it down and move out from the booking. So this one is actually repeating. Yeah, this one is actually repeating. So we can remove these two out and create another table. Okay, so this one is for the second normalization. Okay, so if this part partial dependence is okay, then the last one we have this transitive dependency, which is move this trip guide out from this package table. Okay, some student is well educated. Since this one package we have ID, customer we also have an ID. For booking, we also have this customer ID and package ID. So trip guide here we also have the student also create one trip ID. Okay, so this one trip guide ID or trip ID. Yes, this one is good. Up to you. Okay, so if you add another one here, yeah, I accept it. Okay, so this one is for first normalization, second normalization, and third normalization. You can see from here is about for normalization we have a 12 mark here. Okay, so this one is quite a lot, but also hard to answer. Most students didn't get the good mark for this part. Okay, next one here we have indexing. During our practical class time, at the end of a semester, we introduce this indexing. And we also mentioned for this indexing is more toward if we already understand every table should have one primary key. And this primary key, the system will automatically index based on the primary key. Okay, so we have a student ID, we have a staff ID, just now we have a package ID, customer ID. So all these, the let's say Oracle will automatically indexing based on this ID. So problem here occur when the query searching something that is not ID and it search this table many times every day, checking any of the wages is less than or equal to this amount or greater than this amount. This one during our practical times we mentioned if the searching the use of this staff wages in the query is quite often, then it is good to do this indexing. Okay, so this is the reason why we want to have indexing to some of the attribute. Okay, so the question asks us which kind of indexing we need to use. Because this one is amount. Anything regarding amount, we suggest to use this B plus 3 indexing with the search key of this staff wages. Okay. Then this one is a suggestion or the reason why we want to use this 3 B plus 3 indexing. The reason is the existing index ID is no help, and the searching of these wages is huge. We use this in the query a lot of time, and of course you need to continue to mention whether the wages or the staff or the ID, the relationship department, which one is more than you need to apply this B plus 3 indexing to a specific attribute. Okay, so this one is the case. Okay, so we have based on the price, the wages. So we earning over 90,000. Then I think the question is this one is the whole one. We already try to do some changes to this part. Okay, so this one is the department ID equal to F001, which is the finance. Okay, so based on this question, you need to explain the type of index that you want to apply. So after you understand the B plus 3 indexing, then you give the reason why and how to apply to any of these attributes. Okay, so this one is for question 1. Then I will continue to the next one for concurrency. Okay, so we have one table, one transaction one and transaction two. And the question asks us to create one or two-phase locking. About this two transaction in the table 2A. Okay, so you should have one basic understanding of this two-phase locking first. The two-phase locking protocol, this one, if we want to read one data and maybe we want to do something to this data, what we need to do is we need to lock it first. So before we read it, we need to request for the locking. Okay, so for two-phase locking, you can continue a request for locking whatever attribute, whatever data that you want, and until you finish, then you start unlock. So after you unlock one data, you cannot request for locking of another data again. Okay, so you continue request for locking after process, or you cannot continue the process, you cannot complete the process, you unlock the data, and you won't be locking back again. So it is like a tree. You continue asking for locking of a data, then once you release the lock, then you cannot lock any data again. So this one is what we call two-phase locking. You may need to give a simple explanation for this one. So we have one phase called growing phase. We also have another phase called seeking phase. So growing phase is you continue ask for locking. For the sinking phase, it is you release the lock, but you cannot get a new lock anymore. So this one is what we call two-phase locking. So this one for two-phase locking, it offers this serialization. Try to get some data and doing this concurrency. So if we read A, read B, do something, unlock, then this one is completing of one transaction. If at the same time we have another transaction that is requesting and locking of the data, let's say B, then so we finish with this part. When we want to request for B, since this one read, just now I mentioned already, when you read, you should have one request for locking at the beginning. So for two-phase, for two-phase locking. So this B is already locked by transaction B. So when you read B, before read B, you need to request for locking. This part, it already stopped and waiting. Okay, so for concurrency, until this part, this process or this transaction is in the waiting part. Okay, then the T1 and T2 have a non-serialized schedule that can be serialized. Okay, so we have this keyword serialized. Since this one lock A, this one is log B, and until this part, when you want to read B, the data for B is already locking by transaction 2. So this one is not possible to be serialized anymore. Either this T2 stop here or T1 stop here, unlock A, T2 unlock B, then only it can be continued. Okay, so the answer for this part is it is not possible to be serialized unless either one of these unlockers. Okay, next one. Are there any chances that the schedule for this T1 and T2 will be lead to deadlock? Yes. We just show. Okay, so this one is the scenario. We have this log A, read A for transaction 1. Suppose this one should be from top to down. So based on the table that provide. Okay, so try. So this part T2, we already have this log B. That only you want to start reading. But for T1, it write A, then it log B already. So it log B. This dot 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 saying that it is waiting for the release of the previous T2 data B. So this part it is in the waiting status. For T2, same thing. After it log B, read B, write B, and it log A. So when the time you log A, because A is already logged by T1, so it's in the waiting status again. So this will cause deadlock. Okay, so if you go through this, you actually need to wait and cause deadlock, and it have one time that one time limit that for each of the transaction. If you already log one data for more than how many seconds, you need to release the log, then end the process, end the transaction, request start the transaction again in a certain time. Okay, so this one is for concurrency. Based on the previous SAM's record, concurrency control is always there. Not always, I cannot say always, but it more or less based on a different different way of asking question, it is there. Okay, then the last one here we have this part. We have this chip store. You can compare this with question 1. Previously we have this Mr. Ahmad, which only want to open another store in nearby city. But this cheap store, it has many outlets all over Malaysia to manage the customer order, and every local every outlet have its own local warehouse. So this one is big business. Okay, compared to the one that we mentioned before, Mr. Ahmad, he only want to try to open another. Okay, means a second branch. Okay, so this chip store top management has agreed to disseminate its business between its outlet. So examining the factor. So this one is the main point. Examining the factor to consider in deciding the suitable design strategy for distribute database. So previously we only want to have something to solve the problem, but now this one already mentioned you want to have one distribute database because the shop or the store or the warehouse is all over Malaysia. Okay, so this part you need to mention about the thing that this chip store need to need to consider. Okay, so before we go to the point of the factor that this chip store need to consider, this one is a very good picture that I need to mention. For distribute a database, a logical interrelated collection of shared data is physically distributed all over the computer network. So we have a site 1, 2, 3, 4 computer network. Each one have its own database. And this database, it may be all or it may be only part of the complete database, or some of the DB not even have the table. Okay, so this one is a good picture. A given site may have a local copy of all data, or only part of the data, or not even have the needed, not even have the table. It only need to keep those data or table that is needed for that site. So during a lecture, I did mention some of the production site they only need to keep track something or anything that is related to production. So how many, what is the material, how many go in, how many go out, they may only need to keep track all this. Some others, the sales part, they not even need to bother. Okay, so previously I did mention some of let's say some of the let's say we have one site in remote, and it is doing some kind of a calcium carbonate powder that is used for cement or whatever. So the production only need to keep track how many stone buy in, and after process how many go out. So it need to keep track only this part. So all others sales to which company, they do not need to bother. Okay, so they only have very limited data that is needed in let's say site 4. Okay, so assume site 4 here is the production, and site 1 is the main office. So this main office will have the data for all. Any of the database, it need to synchronize and a copy to site 1. So site 1 will have all the data. Okay, so this one is assumed. You can assume since the question didn't mention and suggest you to assume. Okay, so this part for the question factor to consider in deciding suitable design strategy for distribute the company specification. Okay, so hopefully you understand the point that I mentioned here, and we continue to this part. Okay, so just now I already mentioned for the production side, you only need things that related to production. So if others data that is not needed, then they won't save into their table. So we have this thing called data fragmentation, whether it's horizontal or vertical. Uh, this read back chapter 9 for the distribution. Here, for the data fragmentation, those data that are needed, or those row or column that is needed for that specific site, you only keep track. Okay. Then another one is the data replication. Replication. So the data production that is needed to send back to the main office, which part of the data need to send in, they need to keep track, and when the time is suitable, it will send back to site 1. So just now I already mentioned, this part only keep track of the production, and this one is the main office. The main office not really need to have any data inside here, but just let's say for backup or for monthly this production closing, and they need to keep track until that month end, what is the closing the stock that's due in the site 4. Okay, so until month end, before month until month end, site 4 need to send back all the data to site 1. So this part is the data replication. When is a good time to send back or to synchronize all the data to the related site. Okay, last one, data allocation. Describe the process of deciding where to locate data. Data allocation, we have this centralized partitioning application. So this is the last part. We already mentioned this, and the last part here is the decision where you should put it, whether it's centralized everything or partitioned to the related site, and when it should be repeated. Okay, so this one is for B1, question 2, B1. Question 2, B2, we have this. We have this two table. One is a staff or one is an item. So we assume, just now I mentioned for the production, we have the production product. So this is the product, and each site should have its own stuff. So each site should keep track of all its stuff. The question here is saying that only the headquarter will have this serial processing. So each of the site will have its own item, and only a headquarter will need to have this stuff. So to calculate this salary processing. So during lecture times, I did mention this one is one part. Okay, headquarter will need to calculate the salary. But is it okay that for all the site, it does not need to keep track its own stuff? Yes or no? Okay, up to you to decide. If yes, the each site does not need to keep track of the stuff, its own stuff. This table is only need to store in the headquarter. So next time when you need to do anything, you just need to connect back to the main or headquarter to get all this info. Okay, so this one is up to you to decide. So you need to, based on this, to decide how you're going to partition your table and mention how well you can use this table to how well you can use this table to do the task in a specific site. Okay, so we have suggestions answer for this part. For the distribution, we have this horizontal partitioning. Just now we already mentioned when which table or which row or which column you need to store in a specific site. It is up to you to decide. Okay, so just now for the salary, the staff salary part, only a headquarter need to keep track the staff. So the whole table can save in the headquarter. Then all others side, they need to keep track their own item only. Okay, so this one horizontally partition. If you want to mention about this, then you can say for those site, for those staff in a specific site, they need to keep track of the record as well. Then they need only those staff ID in a specific site stored in a specific database. Okay, so we come back to this part. Oh, we have an example. The salary or the staff database is stored in site 1, main or headquarter. For site 3, they only need to keep track or store table, the record, the staff record in this site 3. Okay, so this one is the horizontal partitioning. Only those record row stored in site 3. Another one, efficiency data are stored close to where they are used. So site 4 only need to keep track the production. Site 2, for our example here, this one, item. So every site will have its own item. Since this one is the chip store, so every site will have its own item and keep track of its own warehouse item. Next, we have local optimization data. Can be stored to optimize the performance for the local access. So when you keep track of the local warehouse, local item, then the speed for accessing this data will be much more faster. Okay. Next one, we have a security data not relevant to usage at a particular site are not made available. So for staff, only site 1 need to hold the staff data. For site 2, it only keep the data for its own staff. So any other site staff is not located in site 2. So this one is the security part. It won't site 2, the DBA won't be able to access any other site 3 staff data as well. Next, we have easy of querying combined data. So for site 4, just now we already mentioned we have efficiency and we also have local optimization. So if you need to access something, let's say customer want to buy something from your site, but you didn't have this product. So you need to check whether any other site have this product or not. So you need to have a query. So which site have this product then maybe you can ask them to send it over. Okay, so this one, you will make this system globally. You can know all other site whether have this item or not. So this one is based on the query. Okay, so this one is some suggestion that we mentioned to the company chip store, saying that the table of this tool, how we going to doing this distribute DDBNS. So this one is something that we need to suggest. So after you understand the horizontal partitioning, efficiency of the data store, local optimization, security, and easier of this query, this one is the point that we need to mention, but at the same time, you need to bring into this chip store, doing some kind of explanation. So this one is a 10-mark question. Okay, so we finish the what we say, the revision based on last semester past year exam paper. Okay, any question before we end? Hero, share about this PowerPoint. Okay. Any more? Okay, I already shared this in classroom, and I also create one classwork for this revision. Pedong, can you do you have on my WhatsApp? Because until now only you respond in the chat room. I need to know when is your exam. I think not all of you doing the same exam, right? So this one is a surprise. So is it okay? We have another section if needed. If you think it's not needed, then it's okay. I can share the past exam paper. Then you try to answer it. Submit to Google Class. I will just do very quick checking and show you the suggest answer as well. Okay. Okay. If you think that you really need to have another section of explanation, let me know. If no, then we end here.